Hi everyone, I thought I'd get you started with looking at your data to get going on your conclusion. Um, so I gave you an example for us to get started with. So before you actually go about writing your conclusion, you need to take a couple minutes to be looking at what your data is telling you. All right. Your data is going to include both the numbers, all right, for the zone of inhibition that you measured, and it's also going to be the pictures. In this particular experiment, the pictures can actually tell you a lot of information as well. You do not want to just look at the numbers and not look at those pictures. So this is an example from a past year that nobody chose to do for their experiment. When you look at your data, you're going to notice that there are lots of data tables. Not all of you were lucky enough to have, but some of you had students that were required to make this extra table at the very beginning where it lists the products and it also lists the active ingredients and the percentage of each. This helps us in drawing conclusions. So if you don't have this, you're going to have to look at your fourth paragraph and what you wrote there, or look back at PBAT assignment number 7, where we made the chart with that information. So then you're going to notice that you have different trials and different data tables. So you have to remember that for each individual zone of inhibition, 3 different measurements were taken. So basically, if we scroll down to look at this, what that means is, remember, they went like 3 different directions across. I forgot I could actually draw on this. Oh, hold on. Is it going to let me draw? It says it's going to let me draw, but then it doesn't look like it is. Huh, not letting me draw. Thought it was going to let me. Sorry. So 3 different directions we took measurements. Although most students, you should see that they probably skipped something like this. This is an example of a source of error that is very clear. Do you guys know what that source of error might be? If you thought to yourself, is that a drip? Your answer is correct. That looks to me like there was a drip that occurred. So that basically made it seem like this zone was higher. You would not actually list this source of error in your experiment if the measurement appears to not include the drip. Okay. If we get real complicated, we can include it, but we're going to try not to include it if it seems like the measurement doesn't include it. All right, so looking back up here, when you're looking at your data tables, you'll see that there are 3 measurements. And then what the student would be required to do is they were required to create an average for each individual zone of inhibition. So this first zone of inhibition for Lysol all-purpose cleaner, trial number 1 is 21.6. The second one is 19.3, and the third is 25. Now, when you look at this, I want you to think a little bit mathematically about it. All right, so, oh, here it is. Now it's reading. What the heck? So Lysol, hold on, let me type. So Lysol, if I look at the range of data for Lysol, it was 19.3 to 25, which is a range. I'm going to just estimate this in my head. It's about 6 millimeters. So basically, one thing I want you to always also think about is how consistent was the data. All right. They were using the exact same process, okay, with each of these Lysols. So this Lysol, they just kept dipping another disc into the cup and then placing it on the agar. And yet, they were not getting necessarily the exact same results. All right. There was a range of about 6 millimeters. Is that bad? Is that good? It's a little bit hard to say. We have to look at all 3 products before we can make that decision. So then we can look at the next one, the Clorox Plus. So again, remember that these are just the measurements. So it just kind of gives you an idea if it was circular or more ovalish in shape. All right. So this one was obviously more ovalish. And then this one must have been more circular because those numbers are a little bit closer. Not much though. But then when we look here, here are different measurements. And as you can see, two of them are very similar. That's nice and close to each other. But then we have this 44. This one sticks out a little bit. This one kind of screams maybe it's this thing called an outlier, which is basically a data point that some errors must have occurred because it's kind of sticking out like a sore thumb. It's not making sense with the rest of the data, and it could possibly throw off your results. We don't know that for a fact yet, but we're going to take note of that. So then we're going to say Clorox. These are just notes so you can kind of see what we're talking about. Range of data was 37.3 to 44. And that was about, oh, I got to do the math again. That was about 7 millimeter difference. Okay, so in some ways they've been consistent. But then you might also want to put possible outlier for trial 3. Because basically that might be throwing off your data. When you average these together, this 44 is going to make your average higher. When maybe if you just included these two, your average would be about 35 and a half. Okay. Where here, it's with the 44 included, it's going to be much higher. And we'll see that down below when we look at the average. So we're going to move on to our next one. Spick and Span antibacterial spray. So look at those numbers. Oh, very round on this one at least. All right, and then slightly oblong for the other guys. And then looking here, this range of data is it's not quite as bad, right? It's a little bit closer together. So we can say, I'll put it in the notes because I'm trying to write things down so I'm not just talking. Spick and Span has a range of 16.6 to 21, which is about, I'm just doing general math, guys. Let's really round that up to 17. So that's let's say about 4.5 millimeter difference. All right, so this one seems to be a little bit more consistent than these other two were. All right, although Clorox might have that weird outlier. These, you see how like these are two millimeter difference, and then these are a little over 2 millimeter difference. That's why I can't call one of these an outlier because they're all kind of the same distance apart. This one's like screaming like that it's so different. Oh, I didn't do my math right, guys. I said this was 7, and looking at it again, I'm sorry, that's why you don't do things in your head. It's actually more of a 10 millimeter difference. So that outlier very might be the case. Here, let's color it. Oops, no, that's not the right thing. I can't see my whole screen because I want to have a split screen for you guys. So let's color that a different color. All right, because hey, that's telling me maybe that's an outlier. You could do little notes on the side. Remember how you can do comments? So you can do little notes along the side for yourself if you feel you need to. And then don't forget this one. Remember, this one you could almost argue might be an outlier, right? Because it's a little bit higher. There's a little bit more of a difference between these two numbers. It's almost 4 millimeter difference, where the difference between these two numbers is about 2 millimeters. So 4 from 25 to 21 versus 2 from 19 to 21. So this could also possibly be an outlier. And the reason outliers, again, are important is because it skews the numbers. That means it basically like messes the numbers up and makes you kind of think something that might not really be true. And I'll try to show you in the data table at the bottom. So they also were required to record their control group. Now, hope was that there would be no zone of inhibition for the control group. That kind of also double checks your procedures a little bit. Make sure you're not accidentally doing something that, say, like mixes in some disinfectant into the water accidentally, and then you go to dip it in and put it in, and you've got a zone of inhibition, which means, oh, things weren't as sterile as they needed to be. Then we're going to look at our summary table, which basically summarizes the trials from each of the other data tables all into one, so you can compare each product to each other a little bit more clearly. And if you want, we can highlight the ones that we're a little unsure of here. And here. Interestingly, they're both in trial 3. I did not notice that before. So I start wondering, I don't know for a fact, but I start wondering, did this person start rushing for the 3rd trial? I don't know it. That's really just a guess on my part. Okay. And interesting, these two are bigger, but this one's smaller than the other one, so that's interesting. So looking at this data, the first thing I ask you to do in your conclusion, just so you know, is to state basically, were they effective? Did they all basically give you at least some antibacterial capabilities by having some kind of zone of inhibition? And the answer is all products at and I'm going to shorten it for now, ZOI. In your paper, please make sure you spell out zone of inhibition at least once, and then you can put in parentheses ZOI afterwards. So like this. In your conclusion, at least once, if not once per paragraph, if you need to, you should do something like this. So basically, you're defining zone of inhibition and then letting them know that ZOI stands for the same thing. Once you do that, you can then say ZOI in your paper. So all products had a zone of inhibition. That's good. Okay, next question. Was there one that was definitively more effective at creating that zone of inhibition and therefore more effective at limiting the bacterial growth? When you look at these numbers, this one screams at you, right? It's so much bigger. It's what, 18, 17 millimeters bigger than either other product. You could say that in your conclusion. You can emphasize it by doing a little bit of math and stating those differences. It strengthens your paper. If that's overwhelming to you, the conclusion outline that I gave you is more simple than that. It does not do things like explain the difference and show how big a difference it is. But this one is definitely much bigger. Now, remember how we said we had this outlier here, right? So this outlier was included in the average, but, and you can't see me doing it, we could try to figure out the math without it. So the math without it, 37.3, oops, hold on, I got it clear, 37.3 plus 34.3. Make sure you press the equal sign on your phone before you divide, or your averages would be wrong. You guys are so lucky that the averages are already pretty much done for you based off of what kind of situation we're in. All right, so my average, and then I divide by 2 to get the full average. So it would bring it down to 35.95 as the average if I took out the 44. So in this case, the question is, does that really change your results that much? What do you think? If your answer is no, it doesn't really change my average that much, then that means, hey, it's not changing the results whether we take this out or leave it in. So that's important to note. So no matter what, we can say with or without including the outlier or Clorox, it had the largest ZOI by a large margin. And you can put it in. Remember I said 35, right? So like 35, 21, 31. So it'd either be about 14 millimeter difference without, and it would be 17 difference, right? 17 millimeter difference with the outlier. Okay, so Clorox basically was most effective. So you can, here, most effective. There you go. All right, so now the next question is, what about your other two products, right? Was there a definitive difference between them? This is where it gets a little trickier, guys. Okay, remember this one has an outlier, right? So just like before, if I do the math quick, all right, so clearing my screen, 21.6 plus 19.3 equals, and then divide by 2 instead of 3. It's kind of like we're going to ignore trial 3 like it didn't happen. My average is then 20.45. That might not seem like a big difference to you, but I would start arguing, that looks a lot more similar. Like this one looks very similar to this one when you do that. Okay. The degree of difference between the numbers tells you basically how much you can trust it, unless we did more trials. You can still state, and we will. Oops. Hold on, I gotta pause. Okay, sorry, I was gone for a second. You probably didn't notice because I paused the recording. But you can literally say, if my computer's gonna work, there it goes. You can say second most effective was Lysol. Second most effective was Lysol. The trick is you can make two different you could decide two different things. Okay, you can say it was second most effective. It's going to be a little tricky though, because sometimes some of you might have a difference of only 1 millimeter in between two different products. 1 millimeter or something close to 1 millimeter is not a substantial difference between numbers. When it's not a substantial difference between numbers, it means I can't trust that sources of error weren't what made one zone slightly bigger than another zone. Okay, you could have accidentally slightly measured inaccurately. Okay, there could have been that one got soaked in the liquid a little bit longer than another one did. It could be a number of things. It could be the lawn. I mean, there's lots of different reasons why two numbers can be different. But when they're super duper close together, it's kind of like saying 97 pennies versus 98 pennies. There's not a big difference between 97 pennies and 98 pennies. They're really not. There's a big difference between, 50 pennies and 75 pennies. Not a huge difference because they're pennies, but you get the idea. So be real careful, because when numbers are super close together, they're not necessarily going to mean that one is more effective than the other. So you could technically say second most effective was Lysol, but you could also easily make the argument. Okay, you could say that Lysol and what's the other product? Spick and Span were equally effective because there was, oops, not three, there was not a significant difference in the sizes of the zones. I need you to understand something. In this particular case, because there's basically 3 millimeters difference, right? At this moment, you can say that this is okay. So you can say Lysol was second most effective. That is perfectly good explanation. 3 millimeter difference is fine. Okay. The trick is some of you might be, say, wanting to do like an asterisk, because I put an asterisk here and an asterisk here. I told you the difference, but if you take out the 25 was not as big, right? So the 21.6 plus 19.3 was 20.45. Okay. And then I would put down here, I put an asterisk, and I would say this was an outlier. Oops. And not included in the average. So if I decide to do this, that changes the difference between them, right? So now all of a sudden we only have 2 millimeter difference. Now you could look at the pictures in a minute and decide, well, like visually, I see a really good difference here. And if that's the case, if you can look at the visuals and they really confirm that there is different sizes going on, okay, then that's a different story. So you got to be a little careful. But the idea here is for both of these, you could, this is the most effective, but you could have also gotten away with saying that they are equally effective if you took out this outlier. Okay? Then they would be closer in range. Okay? But you're just as good with saying for this particular info that that the Lysol was second most effective, because this is not a huge outlier. It could be close to the number that's supposed to be. I don't know. All right. And there is a 3 millimeter difference between these numbers, and 3 millimeters is a decent amount of millimeters in between. But I can tell you, any of you that have 1 millimeter in between your different brands, though that is not a significant difference no matter how much you want it to be. Okay. So you can say which one you think is most effective, but in reality, you're going to have to say that they're going to be equally effective if they're within 1 millimeter of each other because of sources of error. And I can make a little mini video with a little PowerPoint that kind of talks about that more if you need that explained to you, why that would happen. So let's look through our pictures before we go, so we can see if they agree with our finding. Now, I can tell you that this person who did this experiment, they had to repeat this experiment like at least 3 times. And what ended up happening was some of her products were so effective that they were actually melding together on the plate. So the zones of inhibition were kind of interfering with each other. So you couldn't tell where the edges were. So when she basically had to redesign her experiment a little bit and separate them more. So instead of having 4 products on a plate, she ended up doing 2 products per plate. Sorry, 2 discs per plate. So this is her Lysol all-purpose cleaner. This is her control group. You can kind of see it there. All right. And then this is her zone of inhibition. And like we discussed a little bit earlier, this is more than likely a drip. All right, this is her lawn, pretty consistent. And there are some spots over here that it was a little bit less consistent. You might want to be looking in between plates to see if the lawn looks like it's the same thickness or if it's lighter on some plates than others, because the thickness of the lawn can affect your results. So here is the other two trials of the Lysol all-purpose cleaner. Now, if you look at these pictures, even though one might be a little bit, the camera might be a little higher and a little bit lower on another one, you can still see that this might look like it's the same size as this one, but this one here is definitely a little smaller, right? Also, her edges are a little inconsistent. So depending on where she measured her edges, like if she measured her edge here, why is that not doing the thing for me? Here, no, it's not going to highlight it. All right, if she measures it right on the edge, see how this kind of zags out? If she included that zag, it would make her zone look bigger, right? But if she took her measurement from here to here, it would make her measurement a little bit smaller. Same with here. You see how depending on where you took the measurement, remember it's across the diagonal every time. So we don't know. She did not mark on here. Some of you, there'll be marks as to where they took their measurements. She did not mark on here where she took her measurements from. Not a big deal. It was not a requirement. But that's just something to note. Let's scroll down and look at the other ones. So here's spick and span. So spick and span's a little weird because I don't like how it's not a circle. It's very oblong. So like, is this really the zone or is this really the zone of the spick and span? I don't like that. I don't know what exactly occurred. Maybe it was a drip, or maybe she accidentally, like maybe when she put the disc down, it moved a little bit. Do you guys remember when you did the bleach lab? Was it hard to keep your disc in place when you did the bleach lab? Did it like to move slightly? Because that's what this looks like to me when it looks like this oblong. So when I look at this, I think that maybe the zone, I don't know for a fact. Okay. This is just an inference. This is not a fact. That maybe this is the zone for spick and span and that this is not the zone, which means that whenever she took her measurements, it would make it look like her zones were bigger than they were because she probably took a measurement this way and then averaged them together. You can look back at her measurements to see that. And then the same thing really occurred here. All right. Not only did it occur here, but the roughness of the edge almost makes me think that her lawn was a little inconsistent. There was a little break in the lawn somewhere around here that made the zone bigger as well. All right, but generally speaking, these two are consistent with each other, but it's weird because, again, they're oblong, which to me signals that there might have been some movement of the discs, which would be a source of error in the experiment. All right, here's the last spick and span. And again, spick and span's weird, huh? Definitely followed along. And it seems like it kind of follows whichever way the bacteria were placed on. Isn't that weird? It's very interesting, right? You see how the bacteria go this way? And so the lawn goes this way. So the zone of inhibition goes this way. It's very interesting. So it's hard to interpret. Okay, it might be that this is the zone is smaller than it actually was. And then here's our control group. It was fine. And then again, you want to look at the thickness of the lawn. Is the thickness of the lawn the same on all of these? I would not say they're exactly the same thickness, not even on the same plate. You see how this one is thicker on this side? It looks, the lawn itself, just the coloration of the lawn and how much you can see through it kind of tells you about the thickness. So I'm not talking about spots that are missing. These are like spots where where her lawn was incomplete. But this whole side doesn't look like it got as much bacteria on it as this side. We were going to fix that, remember, in our experiment if we actually had done it, because you guys would have been the first class that I would have had draw that line down the middle first before they started making their lawn. It might be a good improvement to add to your experiment for your sources of error. So again, this lawn is not consistently the same thickness. And let's scroll down now and look at the Clorox. So here's your Clorox plus Tilex. This one was so strong, she had to put 1 disc per plate. It was just taking over. Clorox plus Tilex. All right. Big, huge lawn. But you'll notice the edge is inconsistent, right? Like you have to literally decide, do I start my measurement at the first little dots of bacteria I see? Or do you start your measurement farther in where the lawn gets thick again? So like this is an example of how measuring, 2 different people could measure this and get different measurements. All right. So like that is definitely a source of error in this experiment. See how it's so edgy? Okay. Like there's a little bit of bacteria that grow in and then it's not a perfect circle. Not a perfect circle. But the size looks pretty consistent. Well, this one looks a little bit bigger. And an incomplete lawn. See how this looks like a little piece of her lawn that wasn't good? See how that makes her zone of inhibition look bigger, but that could just be the lawn was missing there. So that could also affect the size of her zone of inhibition that she was measuring. So looking at the pictures, if I was going to draw my own conclusions from this, I would actually go with that Lysol was second most effective, because when I look at the spick and span and how it looks on here, all of a sudden I'm like, oh, spick and span is definitely third. All right. So I don't need to worry about saying they're equally effective or anything like that. The visuals confirm that spick and span was third, even though when I looked at the numbers, I was unclear as to the case. But then I look at these and I'm like, oh no, these were definitely bigger. Okay. Than spick and span. Spick and span was definitely a smaller zone. Okay. So then it's a lot easier to do the write-up then, which is good. So that's it for right now. That's one example. If you need me to do others, I actually have more examples on here. I hope that this was helpful in getting you started with thinking about your conclusion. I will be recommending you watch this if you don't. And I'll be making another video explaining the directions for the conclusion more. Have a good day, guys.